Enormous, enigmatic phenomena drift within the vast expanse of space, a subject that has always stirred curiosity and left many questions unanswered. Yet the moment has arrived for a dramatic shift in understanding. The James Webb Telescope has provided us with a glimpse into what exists within these colossal, enigmatic masses, commonly known as black holes. Join us as we venture into the far reaches of one of these sinister realms to discover what lies beneath the surface. If you wish to keep up with the most recent cosmic updates, make sure to subscribe to our channel. Don't forget to like the video and activate the notification bell so more people can join in on this cosmic journey. The story began in 1916 with Albert Einstein's general theory of relativity. Einstein was the first to predict the existence of such objects, despite the fact that the term black hole would not be coined until 50 years later. At the time, his idea had some scientists on board, though others remained skeptical. It wasn't until the late 1960s, during research into the star system Cygnus X1, that something amazing was discovered. A strange, bright blue star was emitting X-rays, which hinted at something far from ordinary. This star was revolving around a massive dark object. Upon closer inspection, scientists discovered that the X-rays were not produced by the star, but were being drawn toward the mysterious entity it orbited. What lay at the heart of that orbit turned out to be a powerful force, consuming everything in its path. This marked the first solid evidence in science that black holes indeed existed. No one knew this discovery was just the beginning of something far more extraordinary. The initial identification of Cygnus X1 triggered an avalanche of additional findings. It was soon determined that there could be up to 100 million black holes in our Milky Way galaxy alone. However, detecting them is exceedingly difficult, so the precise number is still unknown. Current estimates suggest that the number could reach the millions, adding even more weight to their significance in the study of astrophysics. Today, the majority of physicists define black holes as entities where any matter that crosses their threshold gets crushed to a density unimaginable, collapsing into what's known as a singularity. Scientists have explained that, in the event of a fall, objects would be stretched out and disintegrated slowly like spaghetti in an elongated form before reaching the final state of collapse. This is one of a black hole's most terrifying characteristics and the reason why so many are fascinated by these sinister phenomena. Despite the fact that the nearest black hole is situated 500 light-years away, the question remains, do black holes have the power to devour entire planets? In 2021, a milestone in black hole research was reached when researchers succeeded in capturing the first clear image of a black hole, specifically the one in the galaxy M87. The black hole was observed for several nights in a row, each time collecting more evidence that eventually revealed the existence of its structure. This structure has three important layers, showing that black holes are not mere voids, but complex entities with multiple layers that need to be explored to understand them better. Let's break down the first two layers. The outermost layer, the event horizon, is a boundary that surrounds the entrance to the black hole. Once an object crosses this threshold, escape becomes impossible, and it either gets confined there or is dragged further in. The singularity is the black hole's central core, where gravity is so overwhelming and constant that not even light can escape. To prevail against this force, an object would need to travel faster than light, an impossible feat according to our current understanding of physics. It's important to keep in mind that gravity on Earth operates completely differently from that in a black hole. If Earth's gravity were similar to that of a black hole, life as we know it would cease to exist. Once an object crosses the immense event horizon, it faces gravitational forces that lead to the singularity. The singularity itself represents the point where most of the black hole's mass is concentrated, and where the laws of physics, as we understand them, cease to function. Inside black holes, chaos reigns, and even the concept of time becomes distorted. What makes the investigation of black holes so intriguing is that no two are alike. Each black hole is unique in gravitational signature and force. Studying one might give you a wealth of knowledge, but exploring another could require an entirely new approach. It's an ongoing puzzle that never seems to have a definite answer. The challenge for scientists lies in the fact that black holes cannot be studied in the same way as stars or other celestial bodies. Unlike stars, which produce heat and have detectable dust and gas surrounding them, black holes cannot be observed directly. Sending a probe into one is out of the question, as it would be crushed the moment it reaches the singularity. This indicates that our comprehension of these giants of the cosmos is constrained by our inability to study them in person. Observing black holes from a distance, using their effects on nearby objects and light, is the only option. Despite these challenges, scientists have generated a variety of theories about what might exist inside a black hole. One of the most intriguing possibilities is that black holes might be more than just voids, rather, entrances to other realms. According to this hypothesis, black holes could serve as gateways for travel among galaxies, or even between universes. Another fascinating idea is that black holes could be anomalies in a simulated universe, akin to a glitch in the matrix. If we ever develop technology capable of faster-than-light travel, perhaps these black holes could be used as routes to distant corners of the universe. But for now, these hypotheses remain speculative, and scientists are still searching for more specific answers. Might the singularity be more than just an empty void? Could it lead to a wormhole, a shortcut to another galaxy? If this idea proves correct, it would revolutionize our understanding of interstellar travel and open up the possibility of exploring galaxies far beyond our own. If black holes are, in fact, ways to access other galaxies, it would mean that many of the limitations once thought to be impossible in space exploration may not be as impossible as they seemed. On the flip side of the theoretical spectrum, there are those who reject the notion of black holes altogether. A team of scientists led by Enrico Rdi, a researcher based in Tokyo, has proposed a radical new theory. Black holes could be nothing more than holograms. In this case, a hologram is not merely a projection, but an optical illusion or discrepancy. Given the vastness and unexplored nature of space, anything is possible. What do you think? Feel free to share your thoughts in the comments. If you enjoyed the video, please like it and subscribe for more updates. The notion that black holes could be holograms, though far-fetched, challenges everything we think we know about these cosmic giants. If black holes are actually nothing more than projections, it would mean that our current comprehension of time and space could be completely incorrect. This notion is based on the concept of quantum mechanics, which suggests that the universe might not be as simple as we assume. Such breakthroughs would not only deepen our understanding of black holes but could also usher in a new era of astrophysics, one where long-standing questions about the fabric of reality might finally be answered. The connection between general relativity, which governs the large-scale structure of the universe, and quantum mechanics, which governs the tiniest particles, has long been one of science's greatest unsolved puzzles. Black holes, sitting at the crossroads of these two theories, may very well be the key to bridging the gap. One of the most exciting aspects of current research is the growing potential for quantum gravity, a theoretical framework that would unify quantum mechanics with gravity. Scientists believe that inside the singularity, where density becomes infinite and time ceases to exist, lies a hidden truth about the quantum nature of space and time. If we can decode this, it might lead to a theory of everything, a single, coherent explanation of the laws that govern the universe. Meanwhile, observatories like the Event Horizon Telescope continue to refine our view of black holes, and upcoming space missions are being designed to study the gravitational waves that ripple through spacetime whenever black holes collide. These waves, first detected in 2015, have already opened a new window into the cosmos, allowing scientists to hear events that would otherwise be invisible. What's equally fascinating is how black holes continue to inspire not just science, but art, literature, and philosophy. They force us to confront profound questions. What is the nature of time? Does space have an edge? Are we alone, or is there something, or someone, beyond the veil? As we peer deeper into the cosmos, it becomes increasingly clear that black holes are not just destructive voids. They are storytellers of the universe, keepers of cosmic secrets, waiting for us to learn their language. Perhaps, one day, we will. Of black holes, until then, they remain a tantalizing mystery that continues to fuel scientific inquiry, inspiring countless minds to look deeper into the cosmos. Whether they are gateways to other dimensions, out of place in the fabric of spacetime, or simply the result of extreme gravitational forces, one thing is evident: black hole research will likely lead to some of the most groundbreaking discoveries of our time. As we look to the future, we must also keep in mind that the current understanding is just the beginning. With each new observation and each new theory, we are building a more complete picture of the universe and the amazing phenomena it contains. The journey into the depths of black holes is far from over. As we continue to explore these cosmic mysteries, we may just unlock answers to some of the most profound concerns regarding the nature of existence itself. In the meantime, the search for answers continues. The universe is full of unknowns, and black holes are among the greatest enigmas we remain to unravel. With ongoing research and exploration, who knows what the future holds? The study of black holes will undoubtedly be at the forefront of scientific advancement, extending human capabilities to their limits and expanding our understanding and knowledge for many years to come. As the years go by, our exploration of black holes will undoubtedly lead us to new and unexplored regions. With the advent of more advanced telescopes and imaging technologies, such as the James Webb Telescope, our ability to peer deeper into the core of these mysterious objects will only improve. Each new observation presents fresh opportunities to gain an understanding of the most powerful forces in the universe. This ongoing journey of discovery might lead to insights that challenge laws already in place. The fact that black holes, as they exist in physics, appear to defy our fundamental rules of reality is what makes them so intriguing. For instance, once something crosses the event horizon, not even light can escape, making it invisible to conventional telescopes. This phenomenon has sparked a number of heated arguments and a range of theories that question the very fabric of spacetime. What happens inside? How does time behave in a black hole under the influence of such extreme gravity? These questions continue to baffle scientists and drive them to develop new methods of research. There is, however, a growing recognition that the study of black holes could one day offer us profound insights into the universe. These cosmic giants might have solutions to questions that we haven't even considered asking yet. However, they might be more than just endpoints for disintegrating stars, they could be entrances to other dimensions or alternative realities. The idea that a black hole could act as a portal to another universe is certainly a possibility many researchers are considering. But for now, it remains a tantalizing theory with no concrete evidence to back it up. Regardless, the very thought that black holes could be linked to the mysteries of the multiverse is enough to fuel scientific curiosity for future generations. Besides the potential role they could play as gateways, black holes could also provide clues about the origins of the universe itself. If the Big Bang created the universe, could black holes be the key to understanding its final stages? Could the matter that falls into black holes eventually give rise to new universes, perpetuating an infinite cycle of destruction and creation? Though this might sound like science fiction, it's a possibility scientists are actively exploring. As technology advances, more sophisticated tools and models will emerge, and these theories may come closer to being proven. One of the most exciting aspects of black hole research is that it challenges our fundamental understanding of physics. Concepts such as gravity, time, and space become distorted under the immense pressure of a black hole's singularity. The laws that govern our everyday lives break down when confronted with the extremes of a black hole's core. This gives scientists a rare opportunity to investigate the outer limits of known physics, and perhaps discover entirely new laws that, in this sense, control the universe. Black holes are more than just things, they are laboratories in which the very rules of nature are being rewritten. Additionally, black holes also shed light on the nature of dark matter and dark energy, two of the biggest mysteries in astrophysics today. Dark matter and dark energy are believed to make up a vast portion of the universe, however, they remain unnoticed and undetectable through conventional means. Black holes, however, interact with their surroundings in ways that might make clearer the impact of dark matter and dark energy. By investigating how black holes affect the space around them, we may uncover new clues about these elusive components of the universe. As we continue to unravel the complexities of black holes, we are also learning more about the larger cosmic web in which they reside. Black holes are often discovered in the cores of galaxies, and their behavior can provide valuable insights into the dynamics of entire galaxies. They may even play a crucial role in the formation and evolution of galaxies. By examining the relationship between galaxies that host black holes, scientists hope to understand more about the birth, life, and death of galaxies, in addition to the function black holes play in shaping our understanding of the universe. In recent years, the intersection of black hole studies with quantum mechanics has opened yet another frontier of possibility. At the heart of this lies one of the most puzzling conflicts in modern physics, the information paradox. According to quantum theory, information cannot be destroyed. Yet, when matter falls into a black hole and seemingly vanishes beyond the event horizon, it challenges this fundamental principle. Does the information get obliterated, violating quantum laws? Or does it somehow survive, encoded in ways we have yet to understand? This paradox has sparked fierce debates and groundbreaking hypotheses, from Stephen Hawking's idea of information leaking through Hawking radiation to newer concepts involving holographic principles, suggesting that perhaps everything that falls into a black hole is somehow preserved on its surface, like a cosmic ledger. These ideas, while still theoretical, hint at a unification between general relativity and quantum mechanics, a theory of everything that could reconcile the physics of the very large with that of the very small. Black holes, in this context, might not just be astronomical phenomena but bridges to a deeper, more complete understanding of reality itself. Moreover, as simulations grow more accurate and data from telescopes become more refined, we are beginning to model the behavior of black holes in ways never before possible. We can now observe how they spin, how they merge, and how they distort space and time around them. The first image of a black hole's event horizon, captured in 2019 by the Event Horizon Telescope, marked a monumental leap, transforming what was once theoretical into something visible and real. This image, grainy and distant though it was, became an icon of human curiosity and capability, a sign that even the most unreachable mysteries of the universe are not beyond our grasp. In the years ahead, with upcoming missions like the Laser Interferometer Space Antenna, LISA, set to detect gravitational waves in space, we may witness even more dramatic events: black holes colliding, galaxies dancing under the pull of supermassive cores, and potentially the discovery of entirely new classes of black holes, ones that challenge our current models yet again. At its core, the study of black holes is not just about stars or space, it's about confronting the limits of what we know, daring to ask questions without immediate answers, and embracing the unknown with relentless curiosity. These cosmic enigmas remind us that the universe is a vast, unfolding story, and black holes may just be the most thrilling chapter yet.